So the three of us were sitting in class at 7:45 in the morning waiting for Andrew to show up when Mr. Jacobs, the great physics master, gave us our team assignment. We were given a resistor of unknown resistance, well not really because we can just Google it, but for our purposes it's a mystery, and told to calculate its resistance using a graph of voltage versus time. Given that we had basically just woken up, this seemed an impossible task, but we decided to power through our collective senioritis and make an attempt, because colleges hate it when you fail physics. To build our circuit, we connected a 6-volt battery to a resistor, a switch, and a capacitor in series with a voltmeter in parallel with the resistor. Our final circuit looked like this. We then connected the voltmeter to SparkView so that when we closed the switch, the software made a voltage versus time graph that we could use to calculate the resistance value of our resistor.
Prevent some of it.
So what should have happened is that we should have been able to use our log voltage versus time graph to easily derive the resistance of our resistor, because this second graph should have been linear. However, as you might have noticed, it's definitely not. This is because, as you will see if you look closely, for some reason our original graph is not of an exponential decay function. This was something of a dilemma, one that no one, including Mr. Jacobs, could quite find a way out of. Basically, none of us had any idea what went wrong. So we did what any logical person would do in this situation. We zoomed in on a tiny section of our graph that looked sorta linear, and used that line of best fit to find our R value with the following equation. We then took the natural log of both sides. The resulting equation was in the form of y equals mx plus b, where x was time, b was the natural log of the EMF, y was the natural log of voltage, and m was 1 over RC. We set 0.0203, which is the m value of our line of best fit, equal to 1 over RC. We then substituted our C value of 1000 microfarads into this equation to get an R value. Our final R value was 49,000 ohms. The manufacturer value for our resistor was 36,000 ohms with a 5% error value. The accepted range was therefore 34,200 to 37,800 ohms. Our value of 49,000 and our range of 46,550 to 51,450 ohms disagrees with this accepted range because the ranges do not overlap. There is no obvious reason why this is true, since we conducted the experiment properly and there was no problem with our calculations. However, for some reason our log v versus time graph came out not to be linear, which was the source of the discrepancy because we were forced to use only a small piece of our data.